uh, automated speech recognition, which is a superset of the popular NLP related tasks. And test is an OCR model, and that is for determining and understanding the characters from text image, directly converting it to into optical characters, and that is a subset of the computer vision applications. So we'll be just going through the Whisper model for today. We'll have test track sometime in the future. So this is what will be going through. First would be the overview, then how the Whisper is working. Over here we'll get a little bit of technical. Over here we'll just to see how and what are the uses of Whisper we can use in our day-to-day tasks, and just we'll have a little bit of hands-on demonstration for the entire thing. So Whisper is basically an open source model, and it is created by OpenAI. Whisper was open source just recently, about in November 2023, just last year. And the Whisper has pretty outstanding capabilities, and it is one of the most used model for automated speech recognition. There are other models as well, but since OpenAI has made it open source, it is one of the most sought after model in recent times. I can just give a little bit of information on this model. So first of all, it is a speech recognition model. Then after, it is trained on total of 6.8 lakh hours of training, and over this training, it was given multilingual tasks and not just related to one single language, and also it was given multitask capabilities. So it was kind of a supervised algorithm, and it was given the task to also predict the language that it is currently working on, and along with that, it was given the task of translating it at the same time. And transcriptioning is definitely one of the things that it does. And the architecture, it is based upon encoder decoder transformer system, which is mostly used in LLMs nowadays. And then after the training data set, that was spread across wide range of different tasks, which is the 6.8 0.68 million hours of training that I'm talking about. So first one was the speech processing task, and second one was the multilingual speech recognition. Then after the translation of the speech, then after the spoken language identification. Also, along with that, activity detection. So, like for example, we have music at sometimes in which there is just music and there is um, no spoken language. So the model can also detect what are the key elements which are being spoken, and also can understand when there is a need for translation and where there is a need for transcription or not. So this is about a little bit of information. We'll just get a little bit of technical over here. This is just the architecture of how the model is working. We'll try to not get in too much into details. So first of all, this is a sentence. So this is just the multitask training data, which is of 680,000 hours. This is different. There are lots of different category of data sets in here. First one is like transcriptioning. For example, this is an English language. Then after, any another language is there, and this is the result. So this is the training data. This is the output that you are expecting. The training data is in some another language, and the output is in English. And also the training data is in another language, and also the output we are expecting, that is in different language. And no speech, in which just when the music is playing, at that time we are not expecting any output out of it. So this is what is happening right over here, and this is fed into the model. The model starts from here. Before that, it is kind of a logman spectrogram, which is a new frequency based visual representation of the entire audio file, so that we can make uh, a distinction between different time frames, and what the things are being um arriving what the things are arriving at different time frames. So this is just a frequency based visual representation of the entire audio file, and from here it is given into a convolutional 1D layer. There are two of them, and then after a Gaussian linear unit. And this is just for the this is like a filter which is given on top of this spectrogram. And then after this one, that one would be this sinusoidal position encoding. That one would be useful to make a distinction in between the different time frames. So it does a similar task like this, but it just provides us a little bit better accuracy. And then after it is given into the encoder blocks, this encoder is like a miniaturized version of the entire transformer. It will just try to extract the uh, most important matrices out of this entire spectrogram, because it's like there would be lots of information in this spectrogram, but we won't be interested in all of them. We'll be just interested in some of them. So this one would just get those very few details which can provide us a good understanding of the entire data set. And there would be self-attention units, and there are multi-level perceptrons as well. These are we won't get into the details of this. And this thing is followed by the decoder. So uh, this provides a miniaturized version, and this one converts that miniaturized version back into the form of the original data that we had. So this is how the entire transformer works. And along with that, it has multitask tokens which are coming from here. And these multitask tokens are the essential driving piece of the entire model. So when these multitask formats are coming in, so we'll just get into the details over here. So what this does is this multitask format that is able to distinct the Whisper model from another AI ASR models. So for example, this is one of the sentence. I'm not sure which one it is. Okay, it's Italian. So OpenAI is able to understand the language on its own. We don't need to provide which language it is, and also it is able to um, translate the language for us. And we'll just get into the details of this multitask training format. So what it does is that it will just have the previous tokens. It will start out the transcriptioning at a particular time instance. It will have some tokens. It will have information of the current token. It has information of previous tokens, and it has the information of timestamps. These timestamps are coming from here. So when it will start the transcriptioning, it will have two tasks. First one which would be to identify the language. Second one would be to identify if there is any voice activity happening right now. So these two tasks would be happening. And when the language would be detected, our task would be to either transcribe, which is to print it, which is what is happening in here, as well as in here. So this one, here the language tag would be used, and this one where the normal tag would be used, which is for English. And this one translate, this is where the second task would be used. And after this thing is done, we will just time log the current timestamp which is there, get the next tokens, add the time logs after that, and get into the next token after that. So over here, like this is the current token, this is the next token, and this is the next token that we're trying to predict. So this is what happens in usual LLMs as well, where we are just interested in predicting the next token. So this is exactly the same thing that is happening over here. And after that, when it hit the end of the end of the audio file, it will just stop the executioning over there, and then after we'll be ready with our transcribed data file. Now, before we get into the uses, I will just try to run up the demonstration over here, because the inputs would be taking a little bit of time. So what we are doing over here is we are using the Whisper model, um, which is by OpenAI, and it has been open sourced on Hugging Face. So this is the model that we have, and it is pretty useful, and lots of people do follow this model. And the model size is just a little bit on the higher end, which makes it a little difficult to be run on normal systems without GPU. But since the Hugging Face have supported them, the entire learning code to make the models run on local system, that is entirely smoothened, and it's not difficult for anyone to get this model and test this model out. They have also added the information on how to test this model. This is literally the all of the code that we will need. So just this much amount of code, and we'll be ready to test this model. So that is the power of Hugging Face, that it just smoothens out the entire learning curve. And for our current purposes, we will be using the last model, which is the version 3, the large Whisper model, which is about 1.5 billion parameters. So before we begin, we'll just run a couple of code which will initiate the which will initiate the downloading of the libraries. Yes. And yeah, we will let it run in the backend, and we are connected to a GPU as well. Yes. So now coming to the uses that we have for Whisper. So we are aware of the virtual assistants like Siri and Alexa, and they use ASR models to understand what we are speaking and to convert that into their own digital formats. Then after live captioning, that is also one of the most useful tools that we have in YouTube. And then after note taking in meetings, that is also one of the another thing. And as of our day-to-day activities, we can use it um, for understanding customer call services. So for example, if we are working with a client who has requirement to understand the sentiment analysis from the customer call logs, the ESR models are pretty useful over here. We can just convert that into two words, and when we have it in digital format in words, we can just directly run a sentiment analysis algorithm over there. But for this, we'll need a pretty good and decent accuracy. And then after, we can also convert spoken feedback into quantifiable data, and the ones which can provide us rich insights into the customer behavior. So these are just a couple of use cases that I could think about, and this is all I wanted to share for the Whisper model. We'll just get into a pretty small demonstration for that, and this is where I have got the model up and running. So we'll just and also I've got one data for this. So I was able to get up a news related video. This is the video that I got. I'm I'm not sure which news channel. Okay, it is ETV news channel, and this is how the
ఇలా
data was.
కాదు.
And since we are working on Telugu input, so we can also um, incorporate this model into our existing Telugu input as well. So this is one of the video that we have, and the language that is being spoken is Telugu
నువ్వు
over here.
అంటించుకోవాల్సి
And
వస్తోంది.
we'll be just trying to
వైఎస్ఆర్ సంపూర్ణ
transcribe this
పోషణ
one. This video is pretty long. It is of 23 minutes. That's why I got it a shorter one. I converted it into a 5 minutes audio format. This is how our input data is looking like.
పైన జగన్ చిత్రాలే
So this is
కవర్
our input
చేయలేక
data where we are
సిబ్బంది
not able
అవస్థలు.
to understand anything which is being spoken right now. And this is where we have the libraries over here, and these are just a couple of libraries from Hugging Face which would be useful for us. Over here we are just invoking the GPU if it is available, otherwise we'll be just working with CPU. This one is the model ID, which is the model that we want to use, which is the Whisper Large version 3. Now this one is where the actual model would be getting created and the actual model would be getting downloaded. So we'll just download the model. This would come in directly from the Hugging Face hub, which is right over here. So the model is saved right over here, and now running this code, our model is getting downloaded right from this hub over here. Currently, we are downloading the SIPnet tensors for the model, and once that is done, we have the model weights, and we'll be ready to test out the model. Okay, and this is the architecture of the model, the architecture that we just discussed, that there are a couple of layers in there. There is convolutional layers, two of them, then there are embedding layers, and then there are encoders and decoders, all of them. And now we'll be just downloading the tokenizers. The tokenizers would be used for converting the um, the textual information, which is the ones that we can understand, into numeric information which the system can use. So over here, just a pipeline. This pipeline one is useful for converting our input data into a format which the model can understand. Now we'll just import a drive, and once we have the drive, we can directly use the MP3 file that I shared a couple of minutes ago. Okay, the audio file is right over here, and now we'll just get that audio file. We'll be running on two tasks. First one would be the translation task. That one would be the most important one, so that we can understand exactly what is being spoken. And after that, we'll just try to have the output in normal Telugu language itself. And along with that, be having the timestamps as well. The drive has been mounted, and we'll also get the timestamps. So just running this task, and it will just take a couple of seconds for us. since the audio file is about of 5 minutes, it will take us some time over here. Okay, we have got the output, and this is the output that we have got. We'll just get it in a decent readable format right over here. Right. So from that video, this is the text file that we have got, and these are the actual words which are being spoken by. So we have successfully converted a speech-based audio into a textual information along with the exact timestamps that we have. And the accuracy is also pretty decent at sometimes, like it is able to understand which news channel exactly it is and what are the words which are being spoken. And also there are a couple of places at which it is not accurate to that extent. Like for example, over here at places where it just prints out gibberish. So definitely it has a little bit of accuracy problems, but please do understand that we are working on a subset of an Indian language, which is relatively lesser used as compared to English. So when the same thing is tested out on an English audio file, the accuracy that we get is unparalleled as compared to the another ASR softwares. Now we are getting the output in the form of the Telugu text itself. So we'll just test this one out. Right. So likewise, we were able to get the output in English. We are also getting the output over here in Telugu as well. And just there is a little bit of issue over here that we are not getting the timestamps. That is something that we do have to look up into. And this is how the entire ASR software is working, and it is pretty easy and pretty straightforward to use. Like there was just a couple of line of codes that we had to write. Like for example, this is just the pipeline that we had to set, and this is where we had to just invoke the model. That was all that was required. So anyone who is not entirely familiar with the internals and how is it working, even that person is able to create a pretty decent basic model. And we'll leave test-rack OCR model for now. We'll have that sometime in the nearer future. So that is all I wanted to share. I have just two references over here. Please do let me know if you would like to have these references. That is all from my side for Whisper model today. Thanks a lot. I'll stop the sharing now. Are there any questions, by the way?
Damik, you said the translation to English is not accurate, right? So the audio file from the Telugu, if it is translated in Telugu, so the accuracy would be better than when converting to English, or it would be same as when converting to English from Telugu audio file.
Right, that is a good question. Yes, Balu, yes. So it would definitely depend upon the model, the end model that we are using. Like as you are saying that we will just first of all get the transcriptions from the Telugu file itself, and then after we can have it run on the Google Translator API. That is definitely one of the options that we have, but that would in the end depend upon the accuracy of the translator itself. Because as you know, sometimes Google Translation translator that is itself not working up to that level. So it in the end boils down to the end model that we are working on. For Whisper, the translation is done by the Whisper's own translation model itself.
Okay, got it.